Let's determine the derivative of the following function by using rules of differentiation. And we'll leave our answers with positive indices and insert form where applicable. So we are given a function y is equal to 3, which is multiplying the cube root of x squared plus 5 over root of x. Alright, so to solve this problem, to differentiate, first we have to simplify it. So let's express it in this form. Y is equals to 3. So you applying some indices properties. Let's say x squared. So cubic root is the same as power of 1 over 3. Alright, then we say plus. Let's express this last part. Let's say plus 5. Alright, so it's saying over root of x. So this is just the same as over x power of half. Alright, so now we need to express this part as well and simplify this part. Okay, so that's next stage. So let's do likewise. So this is same as 3 in brackets. If we multiply this power and this power, we end up with an x raised power of 2 over 3. Alright, so let me just get rid of this bracket. And let's proceed. So then we have a plus 5. Okay, so we're going to re-express this part. So we use this exponential property which says, let's say you have 1 over 8 power of n. This is the same as saying a raised power negative n. Alright, so we're going to apply that part on this section. So let's say plus 5. This is just saying 5 is being divided with 1 over x raised power of half. And we observe that n is the same as power of half, so we need to re-express it in this way to get rid of it being in the denominator. Okay, so let's do likewise. So if we re-express it, it is the same as saying multiplied by x raised power negative half. Okay, so half was the power. Now it contains a negative sign. Okay, so now we have completely expressed it and it's easy to differentiate. Okay, so to differentiate, if you're not familiar with the concept, I'll just rush through how we are going to do it. Let's say we have a function y is equals to x raised power of n, right? To differentiate, we say the derivative, we do say dy dx, right, is equals to, we drop the power of this term. Okay, so in this case, we are indicating that we are differentiating with respect to x. So n is a constant. So if we drop that power, get an n, then we say x, then we subtract 1 from the power. Okay, so that's the trick which we are going to use to differentiate this function. We have to drop the power and then subtract it with negative 1 on the term we are differentiating x on. Alright, so let's do likewise. So we have our y, let's say our dy over dx, right, is going to be equals to, so let's differentiate this first part. So here we have our power, so we're going to drop it as well. All right, so we're going to end up with a 3, then we have 2 over 3, then x, then we say 2 over 3, which is power, then we subtract with 1, or we can just say subtract with 3 over 3, because it's just the same as 1, right? Then let's just say plus 5, which is a constant, or let's just take, we call this a coefficient. All right, so this is the power. We first drop it before doing anything. We have negative 1 over 2, then we have x, then we have negative 1 over 2, then we have to subtract with 1, which is the same as 2 over 2. All right, now it's time to simplify this whole derivative. We have completely differentiated it. So let's create some space, and let's finish our job. So this is going to be equals to, so if we simplify this first part, this 3 and this 3 cancel out and we're left with a 2, then x, And if we simplify this part, we'll be left with a -1, right? -1/3. Great. Let's move on to the other part. So here we have a negative sign, which means here we also have to put a negative in front, right? Because if we multiply a negative and a positive, it will give us a negative. So we have a -5/2, right? And if we simplify this part, we end up with a -3/2. All right, so let's just write that down. We have a -5/2, then x raised to the power of -3/2. Great. Then let's go to the last part of the question because it requires us to leave our answers in positive indices and in sad form. Okay, so positive indices, it implies that our powers should be positive. In sad form, it implies that we should, when we have fractional powers, we should express them in roots. All right, that's what we are going to do now. So we have our dy dx is going to be equals to. So we observe that on this part where we have negative powers, when I use that property which we highlighted earlier, so we said coming from the other side that let's say we have a raised power, let me just say x over y, right? Negative x over y. This is just the same as saying 1 over a raised power x over y, right? So we are trying to get rid of this negative or this negative on the indices. We have to express it in this way. So it implies that on this term of x, right, we're going to say 2 over x raised to the power of 1/3. Right. Now let's do the same on the other term as well. So we have 5 then over 2. So this x is going to move to the denominator as well, and it will be 3 over 2 its power. Great. Now we will need to express it in set form. Alright, so it seems like we need another steps. Also, this just equals to 2 over. Then this is cubic root x, then minus 5 over 2. And x 3 over 2 is just the same as saying x. Let's put a power of 3 inside, all in brackets raised to the power of 1, right? Which is just the same as saying square root of x cubed, or if you like, you can just express it as x root x, right? Because x cubed is just the same as x squared times x, and if you divide it, it's x squared times x, then x squared will give us an x, and root of x will just give us a root of x. So it's just up to you. So we could leave it as x root x, leave it in this form, or we can leave it in this form. Okay, so this is our solution actually.